This is a brief tutorial on the activity series. The activity series is just an arrangement of elements in order of reactivity, where in our case we'll list the highest activity at the top and the lowest activity at the bottom of the series. Most of the elements that we'll see in the series are metals. This chart shows the activity series, which is by no means all-inclusive. There are certainly other substances you could put in here that are not shown. The most active elements are at the top, where these shaded in blue are reactive with water at room temperature to produce hydrogen gas. They also react with water in the gas phase and acid to produce hydrogen gas. These next ones that are in green here will produce hydrogen gas from steam, that is really hot water or water vapor, and acid, non-oxidizing acids in this case. These in yellow will produce hydrogen gas from non-oxidizing acids like hydrochloric acid or acetic acid only, but not from water. These down here at the bottom are the least active and will not release hydrogen gas from water or acid. Those at the bottom are called inactive acids. Those that occur above hydrogen are called active. Halogens can also replace other halogen atoms in a non-metal replacement, where fluorine would replace chlorine and chlorine would replace bromine and bromine would replace iodine, but certainly not the reverse. Things higher up on the activity series will replace things lower down in the activity series, but the reverse reaction will not occur. For example, if I react silver nitrate with copper metal, I'll produce silver metal in a copper 2 nitrate. The reverse reaction does not occur. That is, if I were to take silver metal and put it in a solution of copper 2 nitrate, I get no reaction. So these replacements do have a direction, and a less active metal will not replace a more active metal, or a non-metal in the case of the non-metal replacements. Highly reactive metals, as we mentioned, will react with room temperature water. For example, lithium will react with water to produce lithium hydroxide and hydrogen gas. Less reactive metals will react with steam or water vapor, but not room temperature water. For example, magnesium will react with water to produce magnesium hydroxide and hydrogen gas. Less reactive metals will react with non-oxidizing acids, but not water. For example, tin will react with hydrochloric acid to produce tin chloride and hydrogen gas, but the tin will not react with water at all, at least to liberate hydrogen gas. Metals that react with water also react with acid as well. Inactive metals will not react with water or non-oxidizing acids. For example, copper, if you try to react it with hydrochloric acid, you will get no reaction because the copper is not high enough on the activity series. Copper will react with concentrated nitric acid to form copper 2 nitrate, nitrogen dioxide, which is a red gas that's given off, and water. If the nitric acid's dilute, it tends to form nitrogen monoxide instead of nitrogen dioxide. So copper plus diluted nitric acid will produce still copper 2 nitrate, but nitrogen monoxide and water, and you notice the stoichiometry is a little different. So in this example, we want to arrange things in order of highest activity to lowest activity. So what we have is gold, calcium, iron, and sodium. So how would we arrange those? Calcium would be the most active on the activity series, and then sodium, and then iron, and then gold. And if you look back at the activity series that I had provided, you can see that that is in fact the order where calcium is most active and gold is least active. So in this example, we want to determine if these single replacement reactions will or will not occur according to the activity series. Here we got magnesium reacting with water, we got nickel reacting with acetic acid, we got gold reacting with lead 2 nitrate, and we got iodine reacting with sodium chloride. So which, if any of those, would occur according to the activity series? You have to look and see if they're active enough to displace the thing in the compound. That is, the element has to displace an element in the compound. Are they active enough? Looking, we find only B is a reaction that will occur. The nickel is active enough to replace the hydrogen gas from the acetic acid. Magnesium in A will not displace hydrogen from water because it's not active enough for room temperature water. The nickel does displace the hydrogen gas from the acetic acid. Gold is way down at the bottom of the activity series. It's not active enough to displace lead. Iodine on the halogen activity series is not active enough to displace chlorine. If you just look at group 7A, you see that the things at the top of group 7A are more active than the things at the bottom, and so you can see that that is certainly the case. This has been a brief tutorial on the activity series.